So today we're going to cover section 4. Today we're going to talk about the probability of disjoint and overlapping events. So let's define what an overlapping or a disjoint event is. They're actually composed of compound events. So when you consider all of the outcomes of two events, and those events could be called A and B, they're called compound events. When we refer to the union of two sets, that would be all of the outcomes for either event A or event B. And that is represented by the first picture there, those two blue circles. And all of these circles look like Venn diagrams. You might have seen Venn diagrams back in elementary school and in middle school. So whenever we refer to the union, it's talking about all of the events that are included in both event A and B, all of the outcomes. When we talk about the intersection of two events, that is only going to be including or listing the events in common. And that's represented by the second picture there. And the intersection of event A and B would just be the red. So it's the overlap of the two events. And then when we talk about when there's nothing in common, that would be that last picture. Notice the circles don't overlap. And that's going to be what we call disjoint or mutually exclusive events, when there are no outcomes in common. When they overlap, that would be like the intersection. So we're going to see two separate formulas. When we talk about overlapping events, when there's something in common, and when they're disjoint or mutually exclusive. So the two formulas for calculating the probability of a compound event is if A and B are any two events, then the probability of A or B, when there is something overlapped, is going to be this first formula here. So this is when the two events are going to be overlapping, because this A and B is going to be the overlap. Now, notice the different conjunction, and I'm talking grammar here. Conjunction, I'm referring to the word or and. So when we did 12.2, we saw the probabilities of A and B. Now, what's going to be joining A and B that we're solving for is going to be A or B. So it's going to have the word or in between instead of and. Now, when the two events are disjoint, where there's nothing in common, another term for that would be mutually exclusive. And when the two events are mutually exclusive with nothing in common, then it's just going to be the simple probability of A plus the simple probability of B. Remember in 12.2, we multiplied the probabilities. Now we're adding them. And you're going to need to find common denominators when we're adding these fractions. Okay, so for example 1, we're talking about rolling a 6-sided die, so a regular number cube. So remember, when we roll a dice, the outcomes we can get are the number 1, 2, 3, 4, 5, and 6. So rolling a dice, they want us to know what is the probability that the number rolled is going to be less than 3 or greater than 5. So notice the word or here. So I'm going to define my events. So I'm going to say that event A is going to be I roll less than 3. Now let's go ahead and list our sample space for the numbers that are less than 3. And those numbers are 1 and 2. Now event B, that's what I underlined in blue there. My event B for this question is going to be rolling greater than 5. And when I roll that dice, there is only one number that's greater than 5, and that's going to be the number 6. Notice out of the outcomes I just listed, less than 3 are 1 and 2, and greater than 5 is just the number 6. Notice there are no outcomes in common. So this is going to be an example of mutually exclusive. So for part A, these events are mutually exclusive, or you could also call them disjoint events. So the formula I'm going to be using to find the probability of event A, which is rolling less than 3, or event B greater than 5, I'm going to write it as probability of A or B, and I'm just going to do the probability of A plus the probability of B. Well, I know that there are a total of 6 outcomes on my dice, and again, A was less than 3, so there's 2 numbers that are less than 3, and then greater than 5, there's only 1 number out of the 6. Do not try to simplify your fractions like we did when we multiplied, because then you'd have to still go back and find a common denominator. So I'm going to leave them as is. I'm going to add my fractions. Remember, when you add fractions, you keep the denominator, but just add the numerator. So this answer as a simplified fraction is 1/2. But if it says to write your answer as a percent rounded to the tenths place, remember, big ideas, even though this will turn into 50%, big ideas, if it says round to the tenths, would expect you to put the 0.0. However, on the quiz that you took yesterday, if you ended up getting something like this, I also accepted without the 0.0. Same thing will happen on the test. If it says round to the tenths place and you have a 0 there, on the test I won't mark it wrong, but big ideas will. Now let's try part B here, and let's define our events. So my event A is going to be rolling a number that is greater than 4. So event A, greater than 4. And those numbers that are greater than 4 are going to be the numbers 5 and 6. Then for event B, this one is an even number, and my even numbers are going to be the numbers 2, 4, and 6. So these are the outcomes I'm looking at. Notice this time I have an outcome in common, and that outcome in common is the number 6. So this is an example of overlapping events because they have an outcome in common. So when I have overlapping outcomes in common, when I go to do part B, it's still probability of event A, which is greater than 4, or event B, even. I'm going to set it up as the probability of event A plus the probability of event B, but this time, because there's an overlap, I have to subtract that overlap. So A and B. So that overlap, there's only one number that overlapped. So 1 over the 6 is the overlap because 6 is in common. My probability of event A here, there's 2 numbers, so 2 over 6. My event B, there's 3 even numbers, so 3 over 6. And then I subtract out the overlap, which is what I had in green. So let's go ahead and add 2 plus 3, subtract 1, and my probability here is going to be 4 over 6, because 2 plus 3, 5, minus the 1, 4 over 6. As a simplified fraction, 2/3. As a decimal, this turns into 0.6 repeating. So as a percent, 66.7%, rounded to the tenths place. So this is when you have an overlap, when something is in common to both of the outcomes. So this is what a standard deck of 52 cards looks like. Now, when we took the quiz, I told you I would not give you a deck of cards question. However, now that I've officially presented it to you on a slide, this is fair game for the test. So you need to understand what a deck of cards looks like. A deck of cards is made up of 4 suits. You have clubs, spades, hearts, and diamonds. The black cards are the clubs and spades. The red cards in the deck are the hearts and the diamonds. There are also face cards in each one of the 4 suits. You have jacks, queens, and kings. So you'll have 12 in total, 3 in each suit. And then there are 13 cards in each suit. In each one of the suits, you'll have an ace, a 2, 3, 4, 5, 6, 7, 8, 9, and 10, as well as a jack, queen, king. So understand what a deck of cards looks like. We will not include the jokers. So for here, it says a card is randomly selected from a standard deck of 52 cards. Find the probability of the given event. So there's 4 separate questions here. So what we need to do is understand what a deck of cards looks like, because I need to decide, am I working with overlapping events or am I working with disjoint or mutually exclusive? So in this particular problem, I'm going to go ahead and I want to find the probability of A or B. So my event A is going to be selecting a 5. So this will be my event A. And then notice it's got the word or a face card. And that's going to be my event B. So what I'm going to be working out here is the probability of A or B. And I need to figure out, what does this look like? So selecting a 5, there are 4 5s in the deck of cards. I have the 5 of hearts, 5 of diamonds, 5 of clubs, and 5 of spades. So 4 of them. And then my face cards, there's actually 12 of them. I have a jack, queen, king for all 4 suits. Notice between event A, the 5s, and the face cards, there's nothing in common. So this is an example of disjoint or mutually exclusive. Nothing is in common. So this one is just going to be the probability of A plus the probability of B. All right, so I'm going to fill in. So let me go ahead and finish part A down at the bottom. So my probability of event A happening, so let me go ahead and rewrite this. So probability of A or B, again, it's equal to the probability of A, which was getting a 5. And I knew that there are 4 5s out of the 52 cards. And then I'm going to add that to my event B, the face card. And I know that there are 12 face cards out of the 52. And again, there's nothing in common. So now I'm just going to add those 2 together. And I get 16 over 52. Again, don't reduce the fractions until after you add. I can now reduce it. I can divide them both by 4. And as a simplified fraction, 4 over 13. As a percent, this would give me 0.3076. So as a percent rounded to the 10th place, 30.8%. Then for part B, this is going to be selecting a face card. So this will be my event A. And my event B is going to be a diamond. This time, I can actually have something that is a face card and a diamond at the same time. I have the jack of diamonds, queen of diamonds, and king of diamonds. So this one is an example of overlapping events. So I'm going to go ahead and my way that I would set this up, or my formula, the probability of A or B, when it's overlapping, you're doing the probability of A plus the probability of B subtracting the overlap. And that'll be A and B happening at the same time. So probability of a face card, just like the question up above, there are 12 face cards, so 12 over 52. Then selecting a diamond, there are 13 diamonds in the deck of cards. And then the overlap, there are 3 face cards that are diamonds. Next, we're going to talk about an ace and a 9. Everybody good? Everybody still need it? All right, let's do this one. So for part C, my event A is going to be getting the ace. And I've got 4 aces in my deck. I've got the ace of hearts, ace of diamonds, ace of clubs, ace of spades. My event B is going to be pulling out a 9. And just like the ace, I've got 4 9s in my deck. 9 of hearts, 9 of diamonds, 9 of clubs, 9 of spades. Notice there's nothing in common when I'm doing event A and B. So these are going to be disjoint or mutually exclusive. So this is going to be the same as example A there. So these are disjoint or mutually exclusive. Either word, they mean the same thing. All it means is there is no overlap here. So for part C, I'm using the same formula I did in A. So the probability of A or B is just probability of A plus the probability of B. No overlap. So there are 4 aces in the deck, so 4 over 52. There are 4 9s in the deck, so again, 4 over 52. And then I'll add them together. I get 8 over 52. I can reduce this. I can divide them both by 4, and it simplifies to 2 over 13. Once I convert this to a decimal and a percent, it becomes 15.4%. I end up getting 0.1538, but rounded to the 10th place, 15.4. And then we have one more dealing with the deck of cards. So for the last one, it wants us to find what is the probability of selecting a 10. So selecting a 10 will be my event A. Selecting a diamond is going to be my event B. So I have a 10 of hearts, 10 of clubs, 10 of spades, 10 of diamonds. So that is my overlap because there's 13 diamonds, but there's only one card that is both, and that would be the 10 of diamonds. So this is an example of overlapping events. So I'm going to use the same formula I used in part B. So for part D, let's come over here to the side. So the probability of A or B happening is going to be the probability of A plus the probability of B minus the overlap. And that overlap is that 10 of diamonds. There's only one. So A and B happening. So for the probability of event A, selecting a 10, there are 4 10s in the deck out of 52. Selecting a diamond, 13 out of 52. And then the one overlap, that 10 of diamonds. I'm going to add 4 plus 13 and then subtract 1. And I get 16 over 52. Notice this is exactly the same answer that I got in part A. Reduce this to 4 over 13. And as the percent, 30.8. Okay. Okay, so the last example says, of 100 students surveyed, 92 either own a car or a computer. 65 own cars. 82 own computers. What is the probability that a randomly selected student owns both a car and a computer? So what we're looking to find is the probability of A and B. And I'm going to define this as X. So I'm going to go ahead and notice there is an overlap here. So my event A is going to be owning a car. And that's 65 over 100. My event B is going to be owning a computer. And that's going to be 82 over 100. And then I also have the or. So that was the beginning part. So probability of A or B, that is owning a car. So car or computer. And that was the 92 over 100. Now, notice I put the over 100. Technically for this problem, because a percent is out of 100, I don't need to necessarily work with these as fractions. However, if they said 90 people were surveyed, then it would have been important that you include the total. So there is a question in the homework where you have to include the number of things they're talking about. So that's why I'm going to work with this as fractions using the 100 as the denominator. So what I need to do is I'm using, because this is overlapping, I'm doing the probability of A or B is equal to the probability of A plus the probability of B minus the overlap. So that A and B. And this is what I'm solving for. So let me fill in what I know. So I know A or B is 92 over 100. I know my probability of A is the 65 out of the 100. My B, the computer, is 82 over 100. And I'm solving for the A and B. And that's what I had said was going to be X. So now, I can go ahead and solve this however you want to solve it algebraically. I'm going to go ahead and combine these two like terms here. 65 plus 82. And I get 147 over 100. And then let me put the 92 over 100 equals. And then the minus X. So I'm working on isolating X. Now if you prefer to add the X to the other side, you can. And then subtract the 92. It really doesn't matter. Let's do that. Let's add the X. You could have just subtracted the 147. Either way, so then it gives me this equals the 147 over 100. And now subtract the 92 over 100. And now I end up with X is equal to 55 over 100. As a simplified fraction, I can divide these both by 5, and this ends up being 11 over 20. So this would be the simplified fraction. However, as a percent, 55%. Or if they just ask you to answer the word problem, you would have said 55 students have both a car and a computer. Yes?
If you put a question like this on a test, would you rather have the percentage or the 55 students have a...
It could go either way. It would probably ask you how many students. In the homework, it's going to ask you for the percent.
And if we didn't write the student on our test?
You would get it wrong if you don't read the question.
Okay.
So you always have to follow, because that's how SATs are tricky. They'll give you these problems, but then they'll ask you for a variation of the answer. Okay, so it's always important to read the little details. Everybody good? All right, now let me do number 8. It's not going to be in the video. So open up your homework wherever you're doing your work for the homework, because you have to include this explanation in your work when you submit your assignment to Canvas. Everybody good? Anybody need me to go back to anything? All right, let me save this.